We are Team Dirt, and we will be presenting our product, chlorophyll. This is Judy Hobbs. She's returned home from Zootopia to help her parents on their family seed farm in the country. With her growing age, her parents aren't able to work the fields and check trial beds as often. Judy can help when she's off duty, risking long hours in the sun, but they can't afford to pay for other labor. Living in the city, Judy has heard of many new technologies and softwares that could help farms, but none seem to be able to effectively reduce her needed cost of cheap labor. With an estimated value of around $47 billion, modern agriculture heavily relies on the global seed industry. The 750 plus American seed companies experience the same two key issues as Judy Hobbs: labor costs and time. Genetic engineering has showed that time taken to create novel seeds may be reduced, but labor remains expensive. A staggering 71% of cost in developing novel plant varieties comes from labor. With the ag tech sector growing at around 20% annually, there has to be a product that can make seed production accessible to family-owned farms at cheap prices.
The solution to this? Chlorophyll. While traditional plant breeders use data from human collection, which is then processed by a human, our model relies on visual data from video, which is then passed to our machine learning model. This produces a 3D reconstruction and extracts some preliminary data from the video. This information is then refined in the phenotyping model, which identifies desired plants. The model leverages two separate machine learning methods. The first one, whose output is on the left, is used to generate a three-dimensional reconstruction of the plant from the 2D video. The 3D structure allows us to represent all the data from the video in a computer-friendly way. One issue that many machine learning models suffer from is called the curse of dimensionality. Higher complexity information, like videos, make it exponentially harder for computers to calculate useful information. The second model, whose output is shown on the right, is used to remove unnecessary parts of the image, further reducing the complexity of the data. This allows the computer to focus on one plant at a time and run in a much more efficient manner. Since our model distills the video into a three-dimensional model first and prunes unnecessary parts of the image, it avoids this unneeded complexity, reducing costs and making chlorophyll more accessible to everyone. Based off of our competitive analysis, there are already some plant breeding optimization algorithms in development. However, none of these apps reduce the time to collect field data. By solely relying on video, our program offloads work from the farmer to the computer, whose labor costs are much more affordable, usually in the range of $1 to $2 an hour. To keep the company profitable, we charge $2 per computer hour and an optional $20 subscription for faster processing times. However, this is extremely affordable and saves plant breeders countless hours and dollars.
In order to bring our product to market, we will start by collaborating with public breeding programs at American land-grant universities in order to build our data sets. We plan to tailor our software towards high-value specialty crops. We will also utilize extension programs at these universities to build a loyal clientele. The US is just the starting point for chlorophyll. We plan to enter European and East Asian markets that are already familiar with agri-tech solutions. After this, we expect to leapfrog into markets in developing countries that lack the skill pool to employ plant breeders in farming operations. With this program, we can optimize and democratize seed production across the globe. Thank you for listening.